This video is a quick review on factoring polynomials. So this first one, we have 4x squared plus 9x. If we notice 4x squared is a perfect square, 9 is a perfect square. So this is because of the plus sign, a sum of squares. So to factor a sum of squares, we have two sets of parentheses. We take the square root of the first term. The square root of 4x squared is 2x. So I write that in the first spot of both parentheses. Then I take the square root of 9. The square root of 9 is 3. I write that in the second spot of both sets of parentheses. I do 1 plus, 1 minus. But because it is a sum of squares, the second term, the 3 in this case, gets the imaginary unit I. And this is how you factor a sum of squares. Looking at this second one, every time we do a factoring problem, you should always look for a greatest common factor first, a GCF. In this case, I notice both terms are divisible by 8. So I want to factor out an 8 from both terms. 8 times 9x to the fourth gives me 72x to the fourth. 8 times a negative 16y to the sixth gets me a negative 128y to the sixth. Now, if I look at what I have left in the parentheses right here, this is a difference of squares. Difference means we are subtracting. And the 9 and 16 in both variables are perfect squares. So, to factor a difference of squares, I start with two sets of parentheses. I take the square root of 9x to the fourth. Well, the square root of 9 is 3. The square root of x to the fourth, I take my exponent and I divide it by 2 since I'm taking the square root, and it's x squared. And we can check it by saying x squared times x squared. Yes, that is x to the fourth. The square root of 16 is 4. The square root of y to the sixth, since it's a variable with an exponent, I take that exponent of 6, I divide it by 2, which is 3. And y cubed times y cubed gives me y to the sixth. Then I have 1 plus, 1 minus, and I cannot forget that GCF that was out in front. Looking at the next one, I notice now that I have a cube. I know 64 is a perfect cube. And if I check, 7 times 7 times 7 gives me 343. So that is also a perfect cube. So because of the plus sign, this is a sum of cubes. With cubes, we have a pattern. If we have something cubed, like this, our pattern is a plus b times a squared minus ab plus b squared. So right now, this is what I have. I have two things being cubed. I want to factor it to this. So I need to identify my a and my b. Well, to get a, I take the cube root of 343x cubed. So I need to think of what number and variable I can multiply by itself 3 times to get 343x cubed. That number is 7. Then I need to take the cube root of 64, and I think to myself, what number can I multiply by itself 3 times to get 64? That number is 4. Now that I've identified A and B, I can plug that into this formula right here. So when I see A, I'm writing 7x. When I see B, I'm writing 4. So this factors to A plus B, which is 7x plus 4. And then I have A squared. Well, that would look like this, which is really the same thing as 7x times 7x. 7x times 7x is 49x squared. Then I want to multiply a times b and subtract it. So a times b is 28x, and I'm subtracting it, so I have a negative 28x. And then b squared is 4 squared, which is a positive 16. And this would be factored. Looking at the next one, again, I have another perfect cube. If I notice, 216 and 125 are perfect cubes, and y to the 6th is a perfect cube. So another sum of cubes. Okay, so I'm going to go ahead and rewrite the pattern down, and I'm sorry if you can hear my dogs in the background. They are going crazy. Okay, so there is the pattern. So I need to take the cube root of this first term. So the cube root of 216x cubed is a 6x. Then for b, I need to take the cube root of the second term, so 125y to the 6th. That is 5y squared. Okay, so anywhere I see an A, I'm plugging in 6x. Anywhere I see a B, I am plugging in 5y squared. So this factors to 6x plus 5y squared. Okay, I have a squared, which is 6x squared, which is the same thing as 6x times 6x. That gives me 36x squared. I have a times b, and I'm subtracting it, so that gives me negative 30xy squared. And then I have b squared, which is a 5y squared squared. Same thing as 5y squared times 5y squared. That gives me a positive 25. Y squared times y squared is y to the 4th. And this is factored completely. Looking at number 5, I have 8x cubed minus 1. I now have a difference, and I have some perfect cubes. So this is a difference of cubes. For a difference of cubes, all I need that negative for is to tell me that it's a difference, and now I don't need it anymore. I have a new pattern. It is a minus b now. And then everything in the second part, the trinomial, is positive. So I have that. I still need to identify a and b. I do it the same way I did a sum. I take the cube root of 8x cubed. That gives me a 2x. I take the cube root of 1. Again, I am not worrying about that negative sign. I am taking care of it in my pattern. And that is 1, and I just plug everything in. So I have 2x minus 1, that's a minus b. I have a squared, which is 2x squared, which is the same thing as 2x times 2x. I get a positive 4x squared. I need to multiply a times b, so 2x times 1 is a positive 2x, and b squared, which is 1 squared, is just 1. And so this would be factored completely. Looking at number 6, I have now I have 4 terms, so I'm not doing a sum or difference of cubes. I'm going to show you how to factor by grouping. So to factor by grouping, I group the first 2 terms together. I group the second 2 terms together. I look in the first set of parentheses for a greatest common factor. So for this, I notice that both terms are divisible by 5, and both terms have an a squared in common. So then I write down what I would have left. So 5a squared times 4a gives me 20a cubed. 5a squared times a negative 5b gives me a negative 25a squared b. Now I look at my second set of parentheses, and I look for the GCF there. I notice both terms are divisible by a positive 2 and a b squared. So when I factor that out, 2b squared times 4a gives me 8ab squared. And 2b squared times a negative 5b gives me a negative 10b cubed. Now that I have this, I can notice that what is inside the parentheses is exactly the same. So I can factor it out like a GCF, or I just write it down once, like that. And then I take what is left over and I pair it together. So 5a squared plus 2b squared. And I have this factored completely. Looking at number 7, again, it's another factor by grouping question. So I group them together. I look for the GCF again. So in my first set, the GCF is a 2p squared, which leaves me with a p plus 1. My second group is a positive 7, which leaves me with a p plus 1. Again, the inside of the parentheses should always match. That's how you check yourself. From there, I just take the two things that match. I write it down one time. It's like I factored out a GCF of a p plus 1. And I take what is left over and I pair it together. 2p squared plus 7. So that is factored completely. The next one, this is one from your homework. So if you're watching this, you can check this from your homework. I have this trinomial. So since it's 3 terms, I'm not going to factor by grouping. But I'm going to show you how to factor with the x in the box just in case you forgot. So if I notice, each one of my terms has an x cubed in common. So or an n cubed, I'm sorry. So my GCF is an n cubed. I need to factor that out first. So when I do that, I'm left with an m to the 4th plus 24m squared plus 144. So from here, I'm going to factor this inside part with the x in the box. Yes, it is to the 4th power, but we can still factor it that way. So I draw my x, I draw my box. I take the first number, m to the 4th, and I multiply it by 144, which gives me 144m to the 4th. I put that middle term of 24m on the bottom of the x, m squared. So now I think to myself, what can I multiply to get the top, add to get the bottom? Well, 12 times 12 is 144, and 12 plus 12 is 24. So that would be a 12m squared and a 12m squared. You have to have the m squared with it because m squared times m squared gives us that m to the 4th. And to be able to combine like terms to get it to be a 24m squared, they both have to have that. So now I can go to the box. My first term goes in the first square. My last term goes in the last square. The two terms I just found fill in the empty spots, like this. And then I look for the GCF. So if I'm looking at this box right here, m to the 4th and 12m squared have a m squared in common. Well, m squared times another m squared gives me that m to the 4th. M squared times 12 gives me a 12m squared. And then m squared times another 12 gives me a 12m squared. So this factors to m squared plus 12 times m squared plus 12. And I can't forget my GCF on the outside. Now, you could leave it like this, but since these are the exact same terms, I can go ahead and write it like this. M squared plus 12 squared. Again, when it's squared, that means I have two of them. So this could be my final answer, or you could leave it like this. It does not matter. Okay, number 9. If I look, I do have a GCF. of an x squared. So when I factor that out, I have x squared, and then I'd have x cubed minus 64. This is another difference of cubes. So I'm going to just write diff of cubes. So a minus b times a squared plus a times b plus b squared. I identify my a by taking the cube root of x cubed. That gives me x. Identify b by taking the cube root of 64, and that gives me 4, and then I just plug it in. Again, I do not need to worry about that besides to tell me that it means a difference of cubes. So when I plug it in, a minus b, x minus 4. A squared is x squared, a times b is a positive 4x, and b squared is 16. This is factored completely. The last one I'm going to work out, number 10. Again, I look for a GCF first. I notice it is 2c. So when I factor that out, I'm left with a c cubed minus a 16d cubed. So again, another difference of cubes. Again, that formula looks like this. And then I'm just going to find a and b and plug them in. So a equals the cube root of c cubed, which is just c. Oh, I messed up. Does anyone see where I messed up? Right here. When I factored out that 2, that number changes to an 8. If you caught that, give yourself a pat on the back. Everybody makes mistakes. So, at least we caught it. Now, when I take the cube root of the second term, which is an 8d to the third power, that gives me 2d. So now I just plug everything in. C minus 2d, a squared, so c squared, plus a times b, so c times 2d is a 2cd, and 2d squared, so 2d squared, the same thing as 2d times 2d, and that gives me a 4d to the second power. So I hope this video helps with the factoring, and I hope you study tonight to get ready for that quiz tomorrow.